Hi. This Thursday is our test two. We had posted a set of practice questions for test two. I want to spend some time explaining the solution for test two. If you go on GeorgiaView under content, scroll down on the left, you will find tests. And inside tests, we have already done test one. If you missed test one, please let me know. We will reschedule. Test two practice question is in this file. The solution key is already there. The test two question, if you click on it, it's gonna open up the 10 question. These are 10 questions selected from chapter 2 and chapter 4 assignment. If you need more practice question, you can go on to WebWork and sign in WebWork and work out your chapter 3 homework. Make sure you write down your solution calculations after checking your solution. If you haven't submitted all your homework for chapter 3, let me know. I'll reopen them, change the date, reopen them so you can submit it. Now for today, I want to try to walk you through all the solution for the test 2 practice question so you kind of have a perception of what kind of question will be on test 2. We are going to focus on annuity and annuity notation. So let's start with the first question. Question number one, Juan purchased annuity for 4,070. That will make 21 annual payment. The first two come in 1 year. If the effective rate of interest is 7.2%, how much is each annual payment? So the $4,070 should be the present value of the future 21 future payment. So if you try to think of it, then the amount of the payment should be the amount of payment multiplied by A21, the annuity notation A21, should equal to 4,070. So if you want to find out the payment amount, you have to take the 4,070 divided by A21. So I showed the calculation for the A21. In fact, A21 with the annuity notation, it equal to 1 minus V to the power N divided by the interest rate I. So in this case, the interest rate is 7.2%, 0.076. So that's what we have here. If you've done the whole calculation, you get 381.7. So that's question one. 4070 divided by A21 with the interest rate equal to 7.2%. Now, question two. Suppose an annuity will provide 20 annual payments, so that number payment is 20. It's annual payment, so you need the annual interest rate. The price that the 21 payment, each one is $1,560. So we have 20 of the $1,560. But you cannot multiply 20 with 1,560 because those payments are not made similar at the same time. You have to look at the time value. What with the first payment coming in 7 years from now, if the nominal rate of interest is 10%, convertible monthly, what is the present value of the annuity? So again, a present value calculation. I draw the timeline on this one. So if you draw the timeline, realize it's 20 payment. It's 20 payment. But the first payment, the time zero is 7 years. The first payment is made coming 7 years from now. So your first payment is made at, if you think about the number of years, the year 7. So I write the Q equal to 1,560. So the first payment comes in at time 7. So if you're using the annuity formula, take the Q multiplied by 820, since we get 20 payment of it, you actually end up calculating the value at time 6, because the annuity notation calculate the present value one time period before the first payment is made. So Q times Q equal to 1,560. Q times A20 will give you the value at time 6, not time 0. So Q times AN actually provided the value, the total value of the cash flow at the time 1 unit before the first payment. Now QA20, Q time, we have the Q, we have the I, we don't have the I. We have I12, 10% convertible monthly. You have to take the 10% divided by 12 to find the monthly interest rate. This payment is paid annually, so you have to turn the monthly interest rate into an annual interest rate. So that means we're gonna have to work out the interest rate I. So you want to calculate QA20 at the bottom calculation, but it's QA20I. The I is the annual interest rate because the payments are made annually. Even though the interest rate are being quoted or are being given in a monthly format, you have to convert it to an annual interest rate. So we figure out the right interest rate. We already have 20, we already have the Q. The QA20 will give you the value at time 6. You have to discount it back to time 0, assuming you got that I calculated. Right, so here we're going to try to find out the I. Now, 1 plus 0.y over 12 is a monthly growth factor. We have to let it grow for 12 months. So raised to the power of 12, that's a growth factor for the whole year. So that's the future value of 1. So you subtract 1 to find out the interest rate per year. So right there, I equal to 1 plus 0.1 over 12 to the 12 power minus 1. That's the I. That's the I we will be using in the QA20I. Now that we have the I, the present value is calculating the time 0 value. So QA20 will give you the time 6 value. You want to go back to time 0 by discounting it. So multiplication of 1 plus I to the power negative 6 is how you discount it back to time 0. Therefore, we work out all these calculations. The I equal to 1 plus 0.1 over 12 to the 12 power minus 1. That means that 1 plus I would equal to I plus 0.1 over 12 to the 12 power. So the 1 plus I can be replaced by 1 plus 0.1 over 12 to the 12 power. 12 power combined with the 20 power, we have a negative 20, negative 240. Those are the formula, expanding the formulas for A20. So you have to find remember the formula for A20, apply that formula, and this require you to know the I. I didn't really solve the I, so I ended up using the formula I, converted back the 10% calculation. I replace the second I, the denominator I. There's no better way than have to figure out the actual I. That's why. And then the last one is 1 plus I to the power negative 6. Now 1 plus I is 1 plus 0.1 to over 12 to the 12 power. So then 12 power 12 times power 6 is power negative 72. So all these calculations applying the calculation that we had for present value and then the calculation for I, and they are all combined, your final answer should be 7,077.97, and that's the solution for the second question, a present value calculation. The question number 3, how many years will it take to exhaust IRA of 160,000 if you withdraw 1,700 every month? Assume the rate of interest of 9% compounded monthly. Now, your interest rate, no matter how you calculate it, should be converted to however the frequency that is in the cash flow. This question, we're withdrawing 1,700 every month, so we need the monthly interest rate. You're gonna take the 9% divided by 12. That's your monthly interest rate because it says compound monthly. That means the 9% is actually a nominal interest rate. So having the interest rate and then assuming we're solving for n, n will be number of months because we're making monthly payment. If you find out number of months, the number of months divided by 12 will be the number of years. So since the payment are being made monthly, finding out number of months will be more appropriate. So here we are. Okay, since we're making monthly payment, we need to find the monthly interest rate. So, and here represent number of months. And 0.09 divided by 12 is the interest rate, which is 0.0075. Okay, so since we're trying to exhaust with end payment, every payment has value of 1,700. We're trying to exhaust all the value. So we're trying to get a payment plan, like how many payment you are paying. So then the present value of the 160,000 will be all exhausted by the end of the end months. And that's the equation. 160,000 equal to 1,700 times AN. Okay. I see it's a present value calculation because according to the question, it looks like at the beginning of a time you have a certain amount of money and you're trying to make a plan. So then after a certain number payment, the money will be exhausted. So the 160,000 is a present value instead of the future value. Okay, you have that at the beginning, not in the end. All right, and then with all that, we have the 160,000 equal to 1,700 times AN. We want to solve for the N. N is part of the formula for AN. So I'm solving for the AN. You divide both sides of the equation by 1,700. We get AN equal to 94.1176. All right, having that a in there, a n equal to 1 minus v to the power n over I. So write that out, and then we can see where the n is supposed to be. And it's all about solving the equation now. We have the I. The I is 0.075. So the last line of the formula, the only unknown is n because I is given. So I didn't plug in the I. Some people would prefer putting the number for I, so the formula look like an equation that has only one variable. But having notation have the benefit that there's less writing and there's also more clear relationship. All right, so we multiply both sides of the equation by I, then move over the 1 and then find the opposite. So 1 plus I to the power negative n equal to 1 minus 94.1176 I equal to 0.075. Okay, and then the to solve for the n is the exponent. You have to take natural log both sides of the equation and multiply the denominator, and that's what we have, right? I realized I forget to put in the number, did I? This is question number 3. I feel like something is missing. Pretty sure I have that solution already worked out. Let me see. I work out if every solution. Just want to load it into the layout. This is question 3, right? This one should have all the number in there. Oh, no. Okay, if I miss that part, let me finish the calculation of it. Right, so we were supposed to calculate the n. N is equal to negative natural log of 1 minus 94.1176. 7647 multiplied by I equal to 0.075, and then divided by natural log of 1 plus I, that's 1.0075. Right, and then we're going to put it into the calculator and finish calculating the n. I feel like something is missing. Oh, uh, well, it's a division, right? I had the multiplication there. Division. So the answer is 1,063. Okay, 1,063.78. Remember, this represent number of months, and the number of months supposed to be integer. If you want to take enough time to exhaust it, we go up, up. So we round up to 164 months. So this is the number of months. So then the number of year will be 164 months divided by 12 because in 1 year there's 12 months. So this division will give you the actual time. We end up having roughly 13 years, 13.7 years. In finance, we use T to represent time in years. And then all the other unit of time, it depends. Like you might have quarterly, you might have monthly, but in this question, the solution should be 13.7. Sorry, I feel like I have done it and then I actually did the calculation on my calculator. I certainly did not put it in. All right, let's move on to question 4. Here we have a perpetuity. It pays $2,000 on January of 1980, 1982, 1984, and so on. We realize we're missing 1981 and 1983 as we were reading the first half of the question. And then it pays X dollar on January 1981, there 1983 and 1985, and so on. So that kind of explains. This is one of the questions that you may see in the Chapter 3 homework assignment. If the present value on January 1st, 1974 is $24,500, the effective rate of interest is 7.4% annually. What is X? Like how much how much payment is into perpetuity? This kind of alternate payment, we have 2000 and then X, 2000 and then X and so on. There are a couple of years about a couple of time label. So I think the best option will be draw the timeline. So try to draw the timeline. So you see, the first payment started as 1980, 2000, and 1981, X, 1982, 2000, 1983, X, and so on. Keep going. It's a perpetuity, so you have an infinite number of payment. Now, the actual time you want to find present value for is 1975, right? Which is like 5 year, 5 years before 1980. Okay, so how do we calculate? I think it's easier to consider as two summation of two perpetuity. See, if you are trying to look at the 2000 payment, 2000 and then 2 years, 2000, another 2 years, 2000. So the frequency of the payment is every 2 years. We need to know the 2-year interest rate, right? So you're not supposed to use the annual interest rate. You have to find out the 2-year interest rate. And let's assume the 2-year interest rate is J. Now, according to perpetuity formula, this you have to check the perpetuity formula in section 3.4. Now, perpetuity formula, how do we do it? It's the number payment divided by the interest rate with that kind of frequency. If you are doing the payment annually, you divide it by the annual interest rate. If you have the payment monthly, you have the payment amount divided by the monthly interest rate. So it's very important to identify the right interest rate. This by every 2-year interest rate, the 2-year interest rate, we're calling it J. So 1 plus J should be equal to a 2-year interest rate. Each year it grew by 7.4%. So for 2 year is 1.074 to the power 2. So J equal to 1.074 to the power 2 minus 1. That's the J. So know how to calculate J. If you want to, you can actually start calculating J immediately. But for me, I want the simple notation, so I kept it as a J. So, and also the perpetuity immediate, the formula calculate the value of it 1 unit time before the first payment. For us, 1 unit time is not 1 year, it's 2 year because the 2000 is being paid every 2 year. So the 2000 over J is giving you the value of all the cash flow 1 unit. This 1 unit is 2 year, 2 year before the first payment. So 2000 divided J give you the cash flow, all the 2000 cash flows value, total value at 1978. If you want to find the value of all the 2000 payment at 1975, you have to discount it for 3 years. All right, and then there's another payment. Another perpetuity is being paid X dollar every 2 years. So the total value will be X over J. We don't know X yet, but we can have a formula to calculate it. X over J is the total value of all the X dollar payment, and you can only calculate it using the annuity immediate formula. Calculate the value of all those payments 1 unit time before the first payment. The first payment is 1981. 2 year before 1981 is 1979. X over J is that value. And then you have the discount for time unit back to 1975. So here we are. And the total present value combining the 2000 cash flow and the X dollar cash flow combined have a present value of 24,500. So the 24,500 equal to the total present value, which would equal to a summation. The 2000 cash flow, you have to discount 3 years back to the year 75. The X over J, you have to discount it 4 unit. And then you can see the reason from the line, the timeline. All right, we know the J. So then in the bottom equation, the only unknown is X. From here, you can put in the actual value for J and do the calculation for the X. This is how I did it. I multiplied both sides of the equation by J. And we know the J, I mean 1 plus J equal to 1.074 to the power 2. Therefore, you can calculate the J. And then we calculate the J. So if you subtract the 24,500 multiplied by the J minus the 2,000 times 1.74 to the power negative 3, that whole subtraction, then you multiply by 1.74 to the power 4, which will give you the value for x. This solution, once you reach the last stage of solving the equation, you can do whichever method that's comfortable to you. But these are all the solution for question 4. This is like testing over how familiar you are about the perpetuated formula. Are you able to determine the time point where the formula is given and the time point when you want to calculate? So there's a discount factor back and forth between along the timeline. So make sure you're able to focus on the exact time you want to calculate. All right, let's move on to question 5. A perpetuity pays $620 annually. At the time of the second payment, the present value of the entire perpetuity is $6,300. What is the smallest possible effective rate of interest? So this question, the unknown is the interest rate, and the cash flow is given. So draw the timeline. So according to this payment plan, we're being paid 620 every year. It's a perpetuity, so we have infinite many payments. The question says, suppose at time 2, which is at the time of the second payment, the value of the entire cash flow is 6,300. What should be the interest rate I? Okay, so I would feel that we can use 620 divided by I to find the total value, which will give you the value 1 unit before the first payment. So then 620 divided by I give you the value at time 0, but we know the value at time 2 is 6,300, and we're gonna move it forward 2 time unit. So 620 divided by I multiplied by 1 plus I to the power 2. This multiplication of 1 plus I to the power 2 determine a future value, like 2 years later, what's the total value. And the both of the 6,360 over I, both of these are representing the time value of the entire cash flow. So all those 620, none of them are missed. So this 6,300 is not the present value of the future cash flow. It's the present value of all the future payment of 620 plus the current value 620 plus the past value of the 620. So all of them considered. That's why I want to calculate the value at time 0 and move forward. That way, no payment was left out. everything is considered. All right, so 620 over I multiplied by 1 plus I to the power 2 equal to 6,300. That's already the equation that has I. All you have to do is solve the I from the equation. So how do we solve it? And there is a plan. This is actually a degree 2 equation. You multiply by both sides of the equation by I, and then we realize there's both sides of the equation have common factor. We divide out the zero. Then we have even number. Divide both sides by 2. We have 31 1 plus I to the power 2 equal to 315I. Then I realized instead of multiply 1 plus I squared equal to 1 plus 2I plus I squared, instead of kind of multiply out, it's easier to turn the I on the right side to I plus 1. So the right side equation could be written as 315I 315 times 1 plus I, then minus 315. Okay, that's why we got this right side equation, 31 times 1 plus I squared minus 315 1 plus I plus 315. Okay, and with that, we can use the quadratic formula to solve for the 1 plus I, because 1 plus I is kind of like the x value. So you have 31x squared minus 315x plus 315 equal to 0. So use quadratic formula, you can solve for the 1 plus I or solve for the x. And that give us 1.1244. Therefore, I equal to 0.1244. That's the whole process of solving the interest rate from a perpetuity. I hope that kind of helped you out with some of the question that we had on 3.4. If you want a more practice question, you might want to go over to your web work homework. Try to finish your 3.4 homework. That kind of give you more of a variety of question to practice. Now, question 6. Insurance company purchase perpetuity due, providing a geometric theory of quarterly payment for a price of 10,000, 100,000 based on annual effective interest rate of I. That's the purchase price, so it must be the present value. Besides, for perpetuity, we can only calculate present value. You cannot calculate future value since there's no definite future. It's a perpetuity. The payment is forever, so there's no last payment. The first and second quarterly payment are 2000 and 2010 respectively. We want to calculate I. So let me draw the timeline. It's a perpetual due. That means the first payment comes at time 0. And assuming the time 0 payment is Q. In this case, Q equal to 2000. The second payment is 2010. And then it's a geometric theory, so we have to have a common factor. Let's assume the common factor multiplied Q is 1 plus J. Then the 1 plus J equal to the second payment divided by the first payment. We get 1.005. That's the J. And the same payment gonna continue, so it's really one Q times 1 plus G to the power K. Okay, then the K will be the time point. Right, so with that in mind, we want to find their total present value. According to the question, the total present value is 100,000, and it should equal to the present value uh, of all the future cash flow. So you have to discount every single cash flow back to time 0. So here we are. At time 0, the Q is still equal to Q, but the time 1 has a Q times 1 plus J. You have to discount it, so time V. The time 2, you have Q times 1 plus J squared, and you have to discount it with power V squared. So without that, we end up getting this calculation. It's an infinite theory. It's a perpetuity, infinite many payment. So we have to calculate present value of infinite many calculation. And we calculated, we can do, what was going on? The computer is frozen. All right, you factor the common factor, which is a Q, and then the rest is 1 plus 1 plus JV plus 1 plus J squared V squared plus 1 plus J cube V cube. It's a geometric infinite sum. According to geometric series summation formula, infinite sum is 1 over 1 minus R. The R will be the common ratio. In this case, the common ratio is 1 plus G times V. right? And then the V equal to the interest rate that we were supposed to calculate. V is the discount factor using the interest rate to calculate. All right, so our ultimate goal is let's calculate the V, and then from the V, we're gonna calculate the I. You would be getting the quarterly interest rate I, and then you raise it up to the 1 year interest rate. So let's first finish the first thing. Let's calculate the V first. So multiply both sides of the equation by the denominator. Okay, and then divide the Q equal to 2000. So 2000 equal 2000 divided by the 100,000 give you the actual number for 1 minus 1 plus GV. So subtract both sides of the equation with 0.02. We get 1 plus G times V is 0.98. Then we know that G is 1 point, the G is 0.05, so 1 plus G is 1.05. Now that's our V. That's the discount factor quarterly, because the payment are made quarterly, okay? So with that, we had the interest rate, calculate I, okay, is that right? Yeah. So that's our VV. It's 0.975 equal to 1 plus I to the negative 1 power. So therefore, the 1 plus J equal to the 0.975 to the negative 1 power. Now, the annual interest rate is, the J is the quarterly interest rate. The I is the annual interest rate. The annual interest rate is 1 plus J to the power 4 because quarter payment applied 4 times. That's your annual interest rate. So the annual growth factor is 1.106. You minus 1 from there, that's your I. So the last line of calculation is how we calculate the annual interest rate. The power 4 is where we're turning the quarterly interest rate into a annual interest rate. That's all the solution that we need for question 6. So I did make it kind of long because I draw the line graph and also try to go through them in detail. It's question 6. Question 7, it's about loan payment. A loan is amortized over 5 years with monthly payment at an annual nominal interest rate for 9% compounded monthly. The first payment is 1,000, is said to be paid 1 month from the day of the loan. Each succeeding monthly payment will be 2% lower than the prior payment. Calculate the outstanding loan balance immediately after the 40th payment. This is one of the questions from 3.8. And again, if you need more practice question, you're welcome to try and complete more questions from the homework web work at 3.8. So let's draw the timeline. The first payment is 1,000. Second payment is 1,000 time 2% lower, so 1,000 time 98%. Q time G, G being the 98%. And then the third payment will be Q times G squared and so on. So what will be the 40th payment? You can see the second payment is Q times G. The third payment is Q times G squared. So the G that we multiply will always be 1 unit. The power is 1 number lower than the time index. So at time 40 is Q times G to the power 39. And then at time 60, it should be Q times G to the power 59. All right. If we want to find the outstanding loan balance at time 40, so the outstanding loan balance, what has already been paid is already paid. So the outstanding balance is what else do you have to pay? It's the present value of any remaining payment. We have made 40 payment already. So if you want to calculate the balance, you want to find out the present value of all the future payment. So the Q times G to the power 40, Q times G to the power 41, until Q times G to the power 59. All that payment, which is a 20 more payment in the future after the 40th payment, we want to find their total value at time 40. So we're going to discount to time 40 because it's a time 40 balance. So the outstanding balance at time 40 is Q times G to the power 40 discounted back to time 40. And then you can see Oh, the V, V1, V2, V20 are discount factor, just so those value are being discounted back to time 40. Now you can see the common factor, Q is a common factor, G to the power 40 is a common factor, V is a common factor, the rest of them are all in the parentheses. All right, using the geometric theory partial sum formula is 1 minus r to the power n over 1 minus r. In this case, R is a common ratio, R equal to G over V. Okay, by now, we already have a plan for the calculation. All we have to do is plug in the number. Abbreviating the number using letters made the calculation shorter, and therefore we can easy to identify patterns. G is 1,000, Q is 1,000, G is 0.98, V is the interest rate is 9%. So the monthly interest rate is 0.0075. There's a missing zero there. So V should be 1.0075 to the power of -1. So that's the calculation. 1,000 times 0.98 to the power 40 times 1.075 to the power -1 times 1 minus 0.98 over 1.075. That's the V. The G is 0.98. The V is 1 over 1.075 raised to the power 40, and then the denominator is 1 minus G times V, which is 0.98 over 1.07. This gives us a whole calculation. It looks like the answer should be B. Again, on the test two, I probably are going to give you the question itself. I will be make them into multiple choice question because I want to see calculation steps. I want to see ideas. Um, Question 8. A loan of $15,000 is to be repaid in an annual installment of, so we have an annual payment of 2,200, the first due in 1 year, followed by a final smaller payment. If the effective rate of interest is 8.6%, what is the outstanding balance owed immediately after the fifth payment? This actually didn't make them into a smaller sequence. Okay, if you draw the timeline, we're talking about the loan balance is, so the loan balance is 15,400. If you are moving forward to time 5, you want to find the time 5 outstanding balance. There's for outstanding balance calculation, there's two methods, the retrospective method and prospective method. The retrospective method is find out the total current value of the loan balance, subtract any payment that has been made. That's your outstanding balance. That's retrospective method. Prospective methods find out how many leftover payment you need to pay. The present value of the future payment is the prospective method. So it depends on whether the past is more clear or the future is more clear. In this question, the past is more clear. The future we don't know. Since it says that we know all the number payment, we know the quantity of each payment, but we do not know how many payments, right? You're paying it off with annual payment of $2,200, and we do not know how many payment we need to make. So at time 5, how many more payment are we supposed to make in the future? We have no calculation yet. So it's easier to do a retrospective method. The loan balance is equal to the loan that was borrowed the money. We borrowed $15,400. At time 5, those 15,400 now is worth 1.086 to the power 5. That's the loan amount counting into the interest rate. Then with 2,200 payment each year, by the time you made 5 payment, then we want to find out those $2,200 payment, the 5 of them, what is their total value at time 5. So this is going to be SN because it's accumulated value. Not the present value, it's actually kind of compared to time 0. The time 5 value is a future value, so we're supposed to use the S5 for its computation. So how do we calculate Sn? Is 1 plus I to the power n minus 1 divided by I. So that's 1.086 to the power 5 minus 1 divided by the interest rate of 8.6%. That's S5. So these calculations provided the outstanding balance, and that will be the solution for question 8. Then there's question 9. Turner buys a new car and finances it with a loan of 22,000. He will make an monthly payment of 450.3 starting 1 month. So there's monthly payment. He will make one larger payment in n plus 1 months to pay off the loan. Payments are calculated using an annual nominal interest rate of 8.4%. That's the annual interest rate, but we're making monthly payment. So there's this necessity of figure out what's the monthly interest rate. That's how we're gonna in your AN or SN formula, you're gonna need the actual monthly interest rate, convertible monthly. So we're gonna take the 8.4% divided by 8, which is divided by 6, right? Divided by 6 is 1.6%. So that's going to be the monthly interest rate that we're using. So with that, we would write 1.4% monthly. Okay, immediately after the 18th payment, he refinanced the loan to pay off the remaining balance with 24 monthly payments starting 1 month later. This refinance loan uses annual nominal interest rate of 4.8% convertible monthly. If we divide that by 6, it's gonna be 0.8. Okay. If you're using a lower interest rate, you're supposed to have a higher payment per month. Okay, so now the question. Calculate the amount of the new monthly payment. So basically, the refinance changes your payment plan. Therefore, you have to rearrange your interest rate and starting the new calculation. This is immediately after the 18th payment, which means we have to find out what is the outstanding balance immediately after the 18th payment. In this case, once again, we have the loan amount, we have the number payment. After the 18th payment, which means 18 months, you can use S18 to find the total value of the 18 payment, take that off the outstanding balance, take out that loan amount, you will be able to find the outstanding balance. So in this case, the outstanding balance calculation is similar to this, to the question 8. Once we get that outstanding balance will be the new loan. We're refinancing it with a different payment plan. This time, we don't have, see, for the first payment plan, we do not know how many payments, that's the end monthly payment we're not given. But the thing is, we are clear about how many payment, 18 payment, then we stopped. We move on to a new loan. In the new loan, the first loan is outstanding balance become the loan amount in the second loan. The number of payment in the second loan is 24. So that's the N. And then we also have the interest rate per month, which is 4.8 divided by 6, 0.8%. So we can calculate the A24, right? We calculate A24 with the new interest rate. So the new loan amount times the A24 would equal to the loan that we borrowed for the outstanding balance at time 18. So the loan divided by the A24 is the monthly payment. That's pretty much the plan. So here is a calculation. The first 18 payments, you will calculate 415.3 times S18. You take that out of your time 18 value of the 22,000. 22,000 is what we borrow at time 0. By the time it's 18, those 22,000 has increased to 22,000 times 1.007 to the power 8. So how do we know the 1.007? You're gonna get your 8.4% divided by 6. That's how we get the I. Um, right? And then so that's the loan amount, right? We are getting a number such as a 16,337.0982. That's going to be your new loan. If you refinance it, you have to have that much money to cover the old loan because you're paying off the old loan and start paying the new loan. All right. So the new loan, the monthly payments, assuming is Q, you're making 24 monthly payment. Now we have the interest rate. The new interest rate is the 4.8% divided by, it's monthly, divided by 12. Oh, I used to divide by 6. That's why I was wrong. 0.048 divided by 12 is 0.004. I was talking about 0.8, but zero point 0.4. So it's 0.4%. That's the J in this page. And so that's how we gonna, this J is what we're using in the A24. You figure out the A24, then the loan amount divided by A24, that's your monthly payment. All the calculation is in this page. If you see anything that you find difficult to understand, you're welcome to mention your questions. That's number 9. It's a refinance example. And number 10. Question 10 is annual effective interest rate I, the present value of a perpetuity paying $10 at the end of each 3-year period with the first payment at the end of the year 3 is 32. All right, that's one perpetuity. And then at the same annual effective interest rate, the present value of perpetuity paying $1 at the end of each 4 months, which is a third of the year, with the first payment at the end of the 4 months is X. We want to calculate the X, assuming these two perpetuity having the same interest rate. So here with my drawing, right? I draw two timeline. The first timeline is to have $10 every 3 years. Okay, remember the present value is 32 here, but for any perpetuity, the present value is the payment amount, which is 10 divided by the interest rate. But in this question, what was the interest rate? It's supposed to be the 3-year interest rate. So what's the 3-year interest rate? The annual interest rate is I, suppose that's I we're solving. So the 3-year interest rate is going to be 1 plus I to the power 3, and then you minus 1. That's a J. So basically we're saying 32 is equal to 10 divided by 1 plus I to the power 3 minus 1. And that would be the equation. And I guess maybe I should be able to write on it so it's easier to follow through the thought process. It's going to be make my messy drawing a little bit more messier. Okay, so the first sentence is giving us the idea the 32 is the present value. So according to the perpetuity formula, for a perpetuity immediate, it's supposed to be the payment amount. In this case, is a $10 every 3 year divided by the interest rate. Here is a calculation for the 3-year interest rate. With that, we can calculate the I. You can see 1 plus I to the power 3 minus 1 is 10 over 32. Therefore, 1 plus I to the power 3 is 10 over 32 plus 1. So that's the 1 plus I itself. And then, of course, subtract 1, you can get your I calculated. Now, back to the second perpetuity. We were supposed to pay $1 at the end of the 4 months. So that means that's the whole year at 1, right? But 4 months is 1/3 of the year, so it's 1, 1, 1. We're getting paid basically $3 for the whole year. And then if you go to 3 years, that's 3 times 3, that's $9. So that's kind of like paying $9 every 3 years. So you can see compared to the first one, it's kind of have a similar cash flow, but yet the first one seems to be slightly higher. But exactly how it is, the present value, what was the present value exactly, which as you can see, it may just end up being a little bit more. So more frequent payment of lower amount may end up being higher than the relative comparable higher, slightly higher value. But anyway, go back to the question. We want to calculate present value. According to the perpetuity immediate formula, present value should be the number payment divided by the interest rate. Now, that kind of like this, right? The number of payment is 1. The interest rate, I'm calling it J. J is the 4 months. That's how frequent the payment is. We're being paid $1 every 4 months. We need the 4 months interest rate. So what exactly is a 4 months interest rate? 4 months is one third of the whole year. For the whole year, you have 1 plus I. That's the 1 plus I. That's the 1 year. So you're going to take that one and raise it to power 1/3. So this is already power 1/3, but 1/3 of this power is going to be 1/9. That's 1/9. So you have to calculate the 42 over 32 raised to the power 1/9. That's the growth factor, and you minus 1. That's the so-called J, the 4 minus interest rate. When I get that number and you go 1 divided by it, that's the whole calculation. That's the calculation, which I think you were getting 32.6. If you wonder how to enter that into a calculator, it goes like this: 1 divided by the J. And then what's the J that we're having? We have, it's 42 divided by 32. We raise that to the power 1/9. 1/9. And then minus 1. So that's pretty much the calculation in this question. Let me double check. All right, so our answer is roughly 32.6. So the answer should be the 32.6 in this case. I hope that explains how it's really one of those questions to understand the relation between the present value of perpetuity to the interest rate. And you have to, perpetuity, the only key component is what is the payment amount and for how frequent they're being paid. The frequency of the payment will determine the interest rate, and the interest rate will actually affect the present value. I hope that will help. That's all 10 questions for the practice question. If you want to be more confident, more prepared, you might want to go over to the whiteboard homework. Make sure that you kind of understand most of the question that was assigned in chapter 3, specifically those ones that are similar to this. All right, that's it. Thank you. Try to stop.